Hi, this next one's called Triangular Treasure in the Seven Caillou series. So they call triangular numbers that because of the equilateral triangular shape that they occupy when laid out as dots. I haven't been in geometry in a while, but those don't look like equilateral triangles. But okay, let's suspend judgment for now. You need to return the nth triangular number. You should return 0 for out of range values. So if you're passed in 0 for n here, return 0. And then 2, notice the answer is 3, right? There's 3 asterisks kind of under the input value of 2. 3 returns 6. If you count those up, 3 plus 2 plus 1, right? 5, 6. And negative 10 is negative, so it returns 0. So not worded well, but I think you can understand what they're going for here. So crank it out. Come on back when you're ready. Okay, so hopefully you found a pattern here with valid inputs starting with n equals 1, n equals 2, n equals 3. If you're still stuck, take this out a few more spots. Go to n equals 4, n equals 5, n equals 6. What would it look like? What would the pictures look like, right? For n equals 4, you would have 4 asterisks on the first row, right? Then 3 below, then 2 below, and then you'd have a 4th row down below with just 1, right? And hopefully you see the pattern is that basically you're summing consecutive integers starting from 1 up into the n value. So where n equals 1, you're summing from 1 to 1, which is just the number 1, equals 1. N equals 2, you've got 1 plus 2, right, which equals 3. For n equals 3, you've got 1 plus 2 plus 3, which equals 6. For 4, you would have 1 plus 2 plus 3 plus 4, right? So it would be what, 7, 8, 9, 10, etc. So think about it. What do we know how to do that will give you the range of numbers from 1 to any arbitrary value that you want? And hopefully that reminds you of something we've used. Enumerable range does precisely that, right? And you tell it what value to start at. In our case, it's always 1. And then you give it a count, which is n, right? We want to go from 1 to n. That's what we just talked about. And so finally, this will generate a collection of values representing each of these rows of asterisks. And then what do you do with those? Well, we added them, right? So what can you do with enumerable collections to add up their values? In case you forgot, you go to your docs, you're in enumerable, right? Under its methods, anything looks like it might add. What's a synonym for add? Sum, right? Sum will take care of that for you. And if you wanted, you could go through a loop and add them up too. I'm just going to stick with link here. They should have an example for you, but it's just like calling any other method. So if they don't, that's fine. See, you got your collection here. You call sum, just like that. So let's do that. Like so. And of course, we got to return it. We should have noticed that sum should say it's what it returns. I have to go to the top. Returns decimal, the sum of the values in the sequence. That was where the type was decimal. We should have an integer one. It's the sum of returns an integer, right? We're summing integer values. That's what we gave the range. So yeah, just like that, call .sum, and that should match with our contract, our little method contract. That's what I like to refer to it as. So we'll go ahead and test. Oh, one thing, right? We're gonna get in trouble if we run like this. What did I miss? System link, right? We got to bring that in. We didn't make up enumerable. We didn't make up range or sum. So bring it in if we're using those libraries. Looks good. Hit the bigger suite of tests. Uh-oh, got in trouble. What do we do? System out of argument out of range exception. Specified argument. Oh, sure. Okay. And a little tell here is, right? What is the name of the test? Negatives should be 0. I mean, that's a well-named test, right? That's kind of giving us an idea what's going wrong here. And one more negative test also hit. What do those have in common? So good job on naming your tests there. You could check out the trace. So not that helpful, but I think we know what's going on, right? Remember in the instructions, they had some bum inputs, 0 and -10. So what do we want to do? How about if we just check before we even process, right? Let's handle that, the possibility of bad input. So we could say if n is less than or equal to 0, right? That would cover 0 and the negative numbers. If it does that, simply return 0. And you know what, if you want to be fancy, you know, keep up with these one-line Wallies out here, we could say return n less than or equal to 0, 0 else that. Let's see if it'll let me do that. Yeah, okay. So yeah, we're just using the ternary operator we learned about before, right? Hopefully you should have seen that syntax before, but if not, just look up the ternary operator. You give a condition first, you follow your question mark, that sort of notes the end of your Boolean condition here, right? Something that returns true or false, n is either less than or equal to 0 or it's not. If it is, you list what to return in the first case, and then you do a colon, and then what to do in the else case, if you will. So yeah, reads pretty well. If it's less than or equal to 0, 0. Otherwise, make that range 1 to n and add the values up. So I'll go ahead and return mine this way. And I can look like the cool kids. Be sure to check out other solutions. And yeah, some fellow ternary operators there. That's leveraging a formula to take to sum up consecutive integers. You know, if you had, it's a good formula to have in your back pocket. So remember that one: n times n plus 1 over 2. You could add up the numbers 1 to 100 really quickly that way. So yeah, that looks more like what we did, right? Except inverted logic, they said if n is greater than 0, then do this one first, else 0. So yeah, same thing, tomato, tomato, right? Go ahead and look at those, see what you can pick up. Otherwise, hit me up in questions, and I will see you in another challenge. Thanks for watching.